I'm Shweta. I taken the topic of data warehouse. This is the introduction part. A data warehouse is defined as a subject-oriented, integrated, non-volatile, time-variant collection of data in support of managers' decision. More generally, data warehousing is a collection of decision support technologies aimed at enabling that knowledge workers such as executive, manager, and analyst to arrive at a better and faster decision. Data warehouse provide access to data for complex analysis, knowledge discovery, and decision making. Style is equal to MSO's space run. They support high performance demands on a organization's data and information. It provides an enormous amount of historical and static data from three tiers: relational databases, multi-dimensional OLAP applications, and client analysis tool. Several types of application tools such as online analytic processing, decision support systems, and data mining are being supported. OLAP is a term used to describe the analysis of complex data from the data warehouse. OLAP is a software technology that allows user to easily and quickly analyze and view data from multiple points of view. OLAP provides dynamic and multi-dimensional support to executives and managers who need to understand different aspects of data activity. Next is activity that are supported include analyzing financial trends, creating slices of data, finding new relationship among data, drilling down into sales statistics, doing calculations through different dimensions where each category of data. There are OLAP tools that use distributed computing capabilities for analysis that require more storage and processing power than can be economically and efficiently located on an individual desktop. DSS support an organization leading decision makers with higher level for data for complex and critical decisions. A DSS queries a data warehouse or an OLAP database for relevant information that can be compared in order to make business decision and predict the impact of that decision. Finally, data mining is being used for knowledge discovery, process of searching data for unanticipated new knowledge. Next is data warehouse architecture, which includes data source layer, data extraction layer, staging area, ETL layer, data storage layer, data logic layer, data presentation layer, metadata layer, system operation layer. Each component is individual below. Data source layer. This represents the different data sources that feed data into data warehouse. The data source can be of any format: plain text file, relational database, other types of database, Excel file, etc. Can all act as a data source. Many different types of data can be data source. Operations, web server logs with user browsing data, internal market research data, third party data such as census data, demographics data or survey data. All these data sources together from the data source layer. Data extraction layer. Data gets pulled from the data source into data warehouse. There is likely some minimal data cleansing, but there is unlikely any major data transformation. Staging area. This is where data sits prior to being scrubbed and transformed into data warehouse. Data mart. Having one common area makes it easier for subsequent data processing integration. ETL layer. This is where data gains its intelligence as logic is applied to transform the data from transactional nature to an analytic nature. This layer is also where data cleansing happens. Data storage layer. This is where the transformed and cleansed data sits based on scope and functionality. Three types of entities that can be found here: data warehouse, data mart, and operational data store. Next is data logic layer. This is where business rules are stored. Business rules stored here do not affect the underlying data transformation rules, but do affect the what report looks like. Data processing layer. This refers to the information that reaches the users. This can be in the form of tabular, graphical report in a browser, and email report that gets automatically generated and sent every day. Metadata layer. This is where information about the data stored in the data warehouse system is stored. A logical data model would be an example of something that's in the metadata layer. A metadata tool is often used to manage metadata. Some system operations layer. This layer include information on how the data warehouse system operates, such as ETL job status, system performance, and users access history. Next is distinctive characteristics of data warehouse. Data warehouse are supposed to be blessed with following unique features: multi-dimensional conceptual view and generic dimensionality, unlimited dimensions and aggregations levels, and unrestricted cross-dimensional operations, and dynamic sparse matrix handling, client-server architecture and multi-user support, accessibility and transparency, intuitive data manipulation, and inconsistent reporting performance. A data warehouse are not much particular about transaction processing. There is increased efficiency in query processing. There are some specialized tools and techniques. They are query transformation, index intersection and union, special rollup, molap and dolap and volap functions, SQL extension, as well advanced join methods and intelligent scanning. Data modeling for data warehouse. Two common multi-dimensional schemas are the star schema and the snowflake schema. The star schema consists of fact table with a single table for each dimension. The snowflake schema is a variation on the star schema in which dimensional tables from a star schema are organized into a hierarchy by normalizing them. First is star schema. All measures in the fact table are related to all the dimensions that fact table is related to. In other words, they all have the same level of granularity. A star schema can be simple or complex. A simple star consists of one fact table. A complex star can have more than one fact table. Let's look at an example. Assume that our data warehouse keeps store sales data, and the different dimensions are time, store, product and customer. In this case, the figure on the left represents our star schema. The lines between two tables indicates that there is a primary key foreign key relationship between the two tables. Note that different dimensions are not related to one another. Next is snowflake schema. The snowflake schema is an extension of star schema where each point of the star explodes into more points. In a star schema, each dimension is represented by a single dimensional table, whereas in a snowflake schema, the dimensional table is normalized into multiple lookup tables, each representing a level in the dimensional hierarchy. For example, the time dimension that consists of two different hierarchies: year, month, day, week, day. We will have 4 lookup tables in the snowflake schema: a lookup table for year, a lookup table for month, a lookup table for week, and lookup table for day. Year is connected to month, which is then connected to a day. Week is only connected to a day. A sample snowflake schema illustrating the above relationship in the time dimension as shown to the right. The main advantage of snowflake schema is the improvement in query performance due to minimized disk storage requirements and joining smaller lookup tables. The main advantage of snowflake schema is the additional maintenance efforts needed due to the increased number of lookup tables. Next is functionality of data warehouses, which includes rollup, drill down and pivot and slice and dice. Rollup. Data is summarized with increased generalization. Drill down. Increasing levels of details are revealed. And pivot. Cross tabulation, that is rotation and perform. Slice and dice. Performing projection operation on the dimension. Next is benefits of data warehouse. The core benefits include historical information for comparative and competitive analysis, enhanced data quality and completeness, supplementing disaster recovery plans with another data backup source. Among the greatest benefit of data warehouse is the ability to analyze and execute business decisions based on data from multiple sources. Finally, conclusion. However, the data warehouse are still an expansive solution and typically found in large firms. The development of central warehouse is a huge undertaking and capital intensive with large potential unmanageable risk. Thank you.